Last section here of chapter 7, we're going to look at graphing systems of inequalities. Okay, so we've looked all chapter at solving systems of linear equalities, equations. Now we're going to look at inequalities. And so example 1 says graph the system. Okay, now I have the luxury here on the screen of having different colors to coordinate, which is nice. You're going to have to do a good job of kind of keeping track of things on your own paper here, and you'll see what I mean in a second. So the first thing is just graph the first inequality. X is greater than or equal to 0. Well, remember, your boundary line here is x equals 0. So you have to graph the boundary line first. X equals 0 is the vertical line, and again, it's going to be a solid line because of that little equal sign there. So here's the first line. That's x equals 0. I'd get in the habit maybe of marking. Okay, and again, you shade everything. X is greater than 0, so that means everything to the right here. Okay, and then for the second equation, it says y is greater than or equal to 0. Again, solid line, and y equals 0 is the horizontal line here, so this is y equals 0. That's your boundary line. Y greater than or equal to 0 means shade everything above this, because that's where the y's are bigger. And so your solution here, okay, is just, so your final graph should not look like this. What it really should look like is not have any of this shaded. You're only looking for where your graphs overlap. Okay, so none of that and none of this. Okay, and again, what you're doing here is you're looking at what points works for both inequalities at the same time. And every single point that lies up here in the first quadrant, and obviously this goes on, forever and ever in every direction here. Every point that lies in that first quadrant will have an x value that's positive and a y value that's positive. That's why that's your solution there. Okay, so again, when you graph these, you're looking for where the graphs overlap. Example 2 says x is greater than 0. So again, it's strictly greater than, so this line now has to be a dash line. So that's the boundary line, x equals 0. X greater than 0 means, again, shade this whole region. Y is less than 0. Again, this has got to be a dash line now. There's your boundary line, y equals 0. Everything less than is down below. But again, I don't want everything down below. All I want is where they're going to overlap. And that region there is where they overlap. And so your solution here should be that right there. Okay, so you have your two boundary lines, and then you have the one region that's going to be a common region for both graphs. Okay, example 4, again, a little bit of legwork to do here. I got to rewrite both equations. So I'm going to take subtract 3x from both sides of the first one. So I get y is less than or equal to negative 3x plus 3. And then I'm going to subtract x from both sides here, and I'm going to have negative y is greater than negative x plus 1. Multiply everything by negative 1. If I multiply by negative, I got to flip the inequality, and that becomes x minus 1. So now I have my two lines that I can graph. The first line, negative 3x plus 3, so positive 3, and then I can go down 3, right 1, down 3, right 1. Okay, the line's going to be a solid line. So there's my first boundary line. Shade everything below it. So it's this whole region here. And the second boundary line, y equals x minus 1. So I go to negative 1, and then it's up 1, right 1, up 1, right 1. And again, it's strictly less than, therefore it's going to be a dash line. And it says is less than, so I shade everything below it. And so this region here that I'm shading, I'll do it in blue, would be where your two graphs intersect. So obviously I have to go ahead and erase all the other stuff I have. Okay, so keep my two lines, and then just the common region stays. So that's what we're looking at here when we're graphing linear inequalities. Example 5 is nice because it's already written in y equals form. So I have positive 2 as my first y-intercept, and then negative 1 is my slope. It's strictly greater than, so it's got to be a dash line. Okay, so something like that. There's my first one. It's everything above it. The second one, y equals 2x plus 5. So positive 5, 1, 2, 3, 4, 5 is going to be way up here Can't really see it, it's off the graph. But then I got to go, I could go up 2, right 1, or I go down 2, 1, 2, left 1, down 2, left 1. And again, that's going to be another dashed line. All right, and again, I should have done this before, but I shade everything above the red one. Okay, so everything above the red one, and then I shade everything below the blue one. Okay, and so hopefully you can see the region that we're really going to be focused on here is where they overlap, and that region is going to be everything right here. Okay, and so again, let me take the time here to erase everything that we don't need on our graph. And again, if you want, you can always just shade and then erase if that works for you. I also got to erase that little bit up there. And there's your graph. Okay, everything below the blue one but above the red one. Now I have 3 of them. This is where it's really going to start getting complicated. So again, the first line, x greater than or equal to 0. So it's got to be a solid line. And everything greater than. Okay, and then for the second one, it's greater than or equal to x minus 2, so -2, and then up 1, right 1, right 1. It's a solid line because it's greater than or equal to. And so here's my second line. Shade everything it's greater than, so everything above it. Well, you'll notice when I'm shading above it, the only region that's going to overlap is right here. That's really the only region I need, because every area where they don't overlap, I'm going to end up erasing anyway. And then I bring my third and final equation into play here, and that is y is greater than or equal to -x minus 2. So here's -2. Negative x means go down 1, right 1. And again, we're greater than or equal to, so it's going to be a solid line, solid line. I'm going to shade everything above it, but again, I'm only going to shade everything above it so that it overlaps the other 2 graphs, and so the only spot that's going to be is right here. All right, so there's the graph of this system of linear inequalities. Again, there's 3 of them. Okay, that's no big deal. You just got to keep track, okay, of where you're overlapping. So again, hopefully that's a pretty good summary there of how to graph systems of linear inequalities. As always, bring questions to class, and we'll be sure to get them answered.